In this video, resultant of coplanar concurrent force systems by 4 more approaches will be discussed. So 11 examples will be presented and they are arranged from simple to challenging ones. So we have the techniques in finding the resultant of coplanar concurrent force systems. One is already discussed in the preceding slides about the parallelogram law and the triangle law by applying the law of cosines and the law of sines. And we will also apply it here, especially for force systems with only two forces, concurrent forces and coplanar, or even if there are forces but the application of this method is applicable or needed. By resolving each force in the system into their rectangular components or non-rectangular components by the techniques discussed in the preceding video on force resolution. That's why the preceding video is on force resolution, so that you are now prepared for finding the resultant of a system where you have to compute first the components of each force. By expressing each force into vector form in rectangular vector representation, so that if it is in vector form and you are asked to find the resultant, then there's no need to specify the angle, just the components in vector form. By determining the standard angle of each force, then applying the formula fx is f cosine theta and fy is f sine theta, then adding corresponding components. By tabulation, putting corresponding components in one column with the use of reference angles. Or here, method 2, this is about reference angles. You should think of the sign. If the force is directed up, rightward, the components are positive. Leftward and downward, components will be negative. Now I have to discuss resultant of general coplanar concurrent force systems, especially if the forces are on the xy plane. Even if they are not in the xy plane, you may superimpose the xy coordinate system, rectangular coordinate system, to facilitate the analysis or the determination of the x and y components of the resultant, then the magnitude as well as the direction of the resultant force. So here is the general force systems. I limit it to 3, but this may be extended to 4 and so on. So we have to arrange these forces according to tip to tail method. The ordering of the arrangement does not matter. You may start with any force, let's say F2, then F1, then F3, or for this case, let's begin with F1, but it doesn't matter. So that's the arrangement. Then the vector that is connected from the tail of the first to the tip of the last, that would be the resultant. Because if you arrange the forces according to tip to tail and the polygon closes, then that means the system is in equilibrium. So this is the x component of F1, y component. X component is negative because it is leftward. F2 has positive x component and positive y component. F3 has a positive x component, negative y component. Then this will be the resultant, R. Then the x component of the resultant, the y component of the resultant, and the angle that the resultant makes with the positive x-axis in standard position. So Rx is the sum of the x components of the forces, negative F1x plus F2x plus F3x. The length of Rx is negative F1x. plus F2x plus F3x, or simply summation forces along x. Ry, on the other hand, is F1y plus F2y plus quantity negative F3y, or simply Ry is the sum of all components of the forces in the system along y. Considering this figure here, we say that the magnitude of R is square root of Rx squared plus Ry squared. And the angle that R makes with the positive x-axis is defined by arctan of absolute value of Ry over Rx. But this is only applicable if theta lies in the first quadrant. Now what if the resultant lies in the first quadrant? Now what if the resultant lies in the second quadrant? Theta should be obtuse. So therefore, arctan of absolute value of Ry over Rx is the reference angle, so that in general, when the resultant lies in the second quadrant, it is 180 degrees minus arctan of absolute value of Ry over Rx. If the resultant lies in the second quadrant, theta is 180 degrees minus arctan of absolute value of Ry over Rx. Although I discussed this in the long videos that I have on statics. So if R lies in quadrant 2, theta is 270 degrees minus arctan of absolute value of Ry over Rx. If R lies in the third quadrant. And lastly, theta is 360 degrees minus arctan of absolute value of Ry over Rx if R lies in quadrant 4. Now, that's it. But if R does not require for the magnitude and theta, just R in vector form, the best way to express the resultant is in vector form because it is already in vector form. Level 1 problem. By 5 methods, determine the resultant of the two forces shown below. So here it is. So solution 1 by parallelogram approach. So we draw lines parallel to the other vector or the other force through the tips so that we can form this parallelogram. So that's the resultant. Then let's call the angle between the 75 Newton force and the resultant as alpha, so that theta is 18 plus alpha degrees. Since this is 80 degrees, remember the principle that the other adjacent angle is 180 minus 80. So this is 100 degrees. And therefore, we can now compute the magnitude of R by cosine law. R square equals 75 square plus 100 square minus 2 times 75 times 100 cosine of 100. So the magnitude of R is 135.0 newtons. Having found the magnitude of R, we can now compute alpha by sine law. 135 as to sine 100 equals 100 as to sine alpha. So alpha is 46.84 degrees. Therefore, we report our answer. R is 135, then angle 18 degrees plus 46.84 degrees. That's 64.84 degrees up to the right or in the first quadrant. So that's it for the first solution. Second method, by standard angle. Since there are only two forces, the 75 Newton force makes an angle of 18 degrees with a positive x-axis. So that's the standard angle. Then for the 100 Newton force, 18 plus 80, its angle is 98 degrees. Actually, we can compute Rx directly by using the formula 75 cosine of 18 plus 100 cosine of 98. But for clarity and because this is the first example, let's compute the component of each first. So fx1 is equal to 75 cosine of 18. So 71.33. You might say this is longer than the first. No, it you can make this short if you compute for Rx directly. There are only two forces. Then Fy1 is 75 sine of 18. I'm just presenting it in a more detailed manner. Fx2 is 100 cosine of 98. So it is negative 13.92. Fy2 is 100 sine of 98. So 99.03 newtons. Then Rx is simply Fx1, 71.33 plus Fx2, negative 13.92, so 57.41. Ry is Fy1, 23.18 plus 99.03, 122.2. So the magnitude of R is square root of 57.41 square over 122.2 square. Both components are positive, so it is up to the right. Then magnitude 135, tangent of theta is Ry over Rx because it is in the first quadrant. So theta is 64.84 degrees. So same answer. Solution 3 by reference angle. The reference angle of 75 is already 18, while the reference angle of 100, the acute angle with respect to the x-axis is this angle here. So this is 180 minus 98, so 82 degrees. Therefore, Rx is 75 cosine 18 positive, 100 is pointed up to the left, so its x component is negative. So Rx is 75 cosine of 18 minus 100 cosine of 82. The reason why it is minus 100 cosine 82 because the 100 Newton force is directed up to the left, so its x component is negative going to the left. So it's the same. Ry on the other hand is 75 sine of 18, then positive also 100 sine of 82 because 100 is pointed upward. So it's the same, therefore the answer would be the same, similar to solution number 2. So there's no need to proceed with this same calculations. Solution 4 by vector representation. The 75 Newton force is 70 magnitude quantity cosine of 18i plus sine of 18j, 18 degrees j. So that would be 71.33i plus 23.18j, 75 cosine 18, 71.33, then 75 sine 18, 23.18. F2 is 100 cosine of 98i plus sine 98j. So expanding, that's negative 13.92 plus 99.03. Then add the two vectors. Then you will have R 71.30 minus 13.92i is 57.41i, then plus 122.2j. That's the answer because this is in vector form. There's no need to present the theta, just the components. That's understood. So the safest way to express the answer if it is required that the resultant must be in vector form is in vector form. Unless otherwise, you have to specify, or it is specified in the problem that you have to compute the magnitude and its direction. But if it is R resultant, then it should be coupled with magnitude and direction, or express it, write the answer in vector form. No issues anymore. The last one is by tabulation, but this tabulated form is similar to solution number 2 and solution number 3. So I will not present it anymore. All you have to do is you draw table, then you put the x components in one table. For example, Rx of the force. So there are two forces. So this would be in the first column for x components, then second column for y component, then you add. Although there is a tabulated form later. And that's it. Level 2 problem. The 500 Newton weight is supported by two cables. The cable forces being F1 and F2. Knowing that the resultant F1 and F2, these are vectors, is a force of magnitude 500 newtons acting in the y direction, determine F1 and F2. So these are just magnitude. To distinguish it with this boldface symbol, so magnitudes only in 5 methods. So solution 1 by parallelogram approach again. So the measure of the angle here is 90 minus 35, so 55. R is 500 newtons magnitude pointing upward. It is stated there in the y direction. So this is 55 degrees and this is 40 degrees, 90 minus 50. So therefore 55 plus 40 is 95. So this must be 180 minus 95, 85 degrees. So this is also 55 degrees, 180 minus 40 minus 85, or equal to this angle. This is 40 degrees, equal to that angle. Remember the property of parallelogram. So from here, we can compute the magnitude of R, or F1 and F2 by sine law. We can compute F1 and F2 by sine law. 500 as to sine 85 equals F1 as to sine 40 equals F2 as to sine 55. So F1 is 500 sine 40 over sine 85, 322.6. F2 is 500 sine 55 over sine 85. So it is 411.1. Solution 2 by standard angle. F1, the standard angle of F1 is from the positive x-axis, 180 minus 35, 145 degrees. Theta 1 is 145 degrees, while theta 2 is 50 degrees automatic. So therefore, Rx is F1 cosine 145 plus F2 cosine 50, and it is equal to 0 because the resultant is purely upward. There's no x component of the resultant. So F1 cosine 145 plus F2 cosine of 50 degrees equals 0. Rx is 0. So you have to analyze that Rx is 0. Ry is equal to R equals positive 500 on the other hand. So Ry equals F1 sine 145 plus F2 sine 50 degrees equals 500. Equation 2. So solving these two equations simultaneously will give us same results. F1 322.6, F2 411.1 newtons. Solution 3 by vector representation. F1 is magnitude of F1, quantity cosine of 145. By the way, R is 0i, that's why x component is 0. Then the y component is 500 newtons. So F1 in vector form is magnitude of F1, quantity cosine of 145 degrees I plus sine 145 degrees J. F2 is magnitude of F2, quantity cosine of 50 degrees I plus sine 50 degrees J. So x component F1 cosine 145 for the second F2 cosine 50 equate to 0. So F1 cosine 145 plus F2 cosine of 50 degrees, add these components here, x components, equate to 0 because Rx is 0. F2, F1 sine 145 plus F2 sine 50 degrees equals 500 because Ry is 500 equal to R. So these equations are similar to that. So therefore, the answer will be the same. Then solution for reference angle. The reference angle of F1 is 35, but it is directed up to the left, so its x component is negative. So Rx is negative F1 cosine 35, then plus F2 cosine 50. F2 is to the right, so positive cosine 50, F2 cosine 50. Then equate to Rx, which is 0. Then for y component, F1 is positive, so F1 sine 35, F2 is also positive because it is pointing upward. F2 sine of 50 degrees equals Ry, which is 500, equal to R. So solving these two equations simultaneously again will give us the same answers. And lastly, by tabulation. So force, F1 and F2. X component of F1 is this one going to the left. Using the reference angle, it is negative F1 cosine of 35, the X component. Then its Y component is upward, so F1 sine 35. So that's why it is very similar to solution 2 and solution 4. For force F2, its X component is positive F2 cosine 50. Its Y component is positive F2 sine of 50. So adding this equate to Rx, which is 0. So negative F1 cosine 35 plus F2 cosine 50 is the same as this, then equals 0. Then F1 sine 35 plus F2 sine 50 is the same as that, equals 500. Then because it's the same as these equations here, then the answers will be the same. So it's not, the answers are not shown here because we ran out of space. Level 3 problem. Two forces are applied to the construction bracket as shown. Determine the angle theta which makes the resultant of the two forces vertical. Determine the magnitude of R of the resultant. So vertical, because the components are downward, then it is negative going down. So although the figure is 3D, but the components of F1 and F2 are only along X and along Y. There's no component along Z. So from the figures, solution, let's select. Let's now have the general resultant of general coplanar for system, concurrent for system. So let's make use of the angles. F1 is directed towards the positive x-axis, so its x component is positive. F2 is directed towards the negative x-axis, so its x component is negative. And there is no Rx. Rx is 0 because the resultant is theta there downward or vertical. So therefore, 4,000 cosine of 70 positive minus 2125 cosine of theta negative equals 0. That's Rx. So 4,000 cosine 70, the x component of 4,000, which is positive, then 2125 is negative because it is going to the left, going towards the negative x-axis. Then equate to Rx, which is 0. From here, we can solve for theta. 4,000 cosine 70 over 2125, then inverse cosine. So theta is 49.92 degrees. Then summation forces y. The y component of 4,000 is 4,000 sine 70 negative. Then 2125 sine of theta negative also downward, then equate it to Ry or R, which is negative. So Ry equals negative 4000 sine 70, then minus 2125 sine of theta, which we already computed, then equals R. Ry equals R equals negative 5385. Since the question is determine the magnitude R of the resultant, then its magnitude is not negative. It is positive 5385 because it's just the magnitude. Level 4 problem. Two rods and one cable are attached to the support at O. If two of the forces are as shown, determine the magnitude F, remember magnitude F and direction theta of the third force so that the resultant of the three forces is vertically downward with a magnitude of 6,000 newtons. In other words, R equals Ry equals negative 6,000. So, since the resultant is downward, again, there's no x component of the resultant, so Rx is 0. So, equate all the sums of the x components to 0. Let's begin with 5,000. It is positive. 5,000 cosine 45. Let's use the reference angle. There's only one method here, so you have to select. It's up to you which method would you want to apply, the most convenient for you. So 5,000 cosine 45 plus 2,500 cosine 30, then minus f sine theta. This is f sine theta minus negative minus f sine theta. It is negative. Opposite of theta is this component. Then equals 0 because Rx is 0. So form f sine theta. It is equal to 5,700.6. Call that equation 1. Then Ry is negative 6,000. 5,000 sine 45 is negative, so this is negative 5,000 going down. Negative 5,000 sine 45. Ry equals negative 5,000 sine 45. Positive 2,500 sine 30. Then negative f cosine theta going down. Then equals negative 6,000. So form this equation f cosine theta. It is negative 5,000 sine 45 plus 2,500 sine 30, then plus 6,000. Transpose that to the right. So f cosine theta equals 3714.47. Call that equation 2. Then divide equation 1 by equation 2 so that you can cancel f and we can compute theta. So f sine theta over f cosine theta equals 5,700.6 over 3714.47. So cancel f. This is tangent theta equals the right side. So we can now compute theta inverse tangent of the ratio in the right side. 56.91 degrees. Then substitute this theta into equation 1 to solve for f. F sine of 56.91 degrees equals 5,700.6. So we can now compute the magnitude of F, 6804 newtons to 4 significant figures. Level 5 problem. Determine the resultant R of the three tension forces acting on the eye bolt. Find the magnitude of R and the angle theta, which R makes with the positive x-axis. So there's only one solution. The best one is component method. So Rx, so resultant R means vector, angle theta, just the angle theta that R makes with the positive x-axis. So let's begin with 20. It is x component is positive going to the right. It is 20 sine of 30, opposites of 30. So 20 sine 30. This is also positive. 8 sine 45, then 0. So Rx is 20 sine 30 plus 8 sine 45. So Rx is equal to 15.657 kilonewtons. Ry is 20 cosine of 30, positive, then minus 8 cosine 45, minus 4. Ry is 20 cosine of 30 minus 8 cosine 45 minus 4. So Ry is 7.664 kilonewtons. Therefore, since Rx and Ry are positive, the force R is directed in the first quadrant, or it lies in the first quadrant. So the magnitude, square root of 15.657 square plus 7.664 square. So R is 17.43 kilonewtons. That's not the answer. That's only magnitude. We are asked for the vector. So it must be coupled with the direction theta. Theta is arctan of 7.664. Ry over Rx 15.657. So theta is 26.08 degrees. So the complete answer is R is 17.43 kilonewtons at theta equals 26.08 degrees because this is in standard form. So I hope that for the first 5 problems, you can still follow and you enjoyed. Level 6, determine P and theta so that the 3 forces shown are equivalent to the single force R, 85I plus 20J kilonewton. So this is the resultant, X component 85, Y component 20 kilonewtons. This is the figure. So from the figure, the X component of P is P cosine theta, positive. The X component of 40 is also positive, P cosine 60, then minus 30, then equate to 85. So Rx is 85 and it is P cosine theta plus 40 cosine 60, then minus 30. Simplifying, P cosine theta equals 95. Call that equation 1. Then Ry P sine theta positive minus 40 sine 60. No y component. 30 has no y component. Then equals 20. So Ry equals 20 equals P sine theta minus 40 sine 60. Simplifying, P sine theta equals 54.641, equation 2. So to solve for theta first, divide equation 2 by equation 1. So P sine theta over P cosine theta equals 56.641 over 95. Cancel P, tangent theta equals this ratio in the right side. So we can now compute for theta, inverse tangent of this ratio. So theta is 29.91 degrees. Substitute into equation 1 to solve for P. So P cosine of 29.91 degrees equals 95. So P is 109.6 kilonewtons. So the solution is short and I hope you can still follow. Level 7, the 3 forces, each of magnitude F, are applied to the crate. Determine F, so just the magnitude, so that the 3 forces are equivalent to a single 1,200 Newton force. So this is the given figure. So first, let's have the resultant of the first two. We cannot compute the X component here because there's no angle, definite angle that each force makes with the x-axis or the y-axis. So let's apply parallelogram law. Let's have the resultant of these two. Because they are equal, definitely that resultant divides the 45-degree angle, but we have to verify it to check if our solution is correct. So let's combine the resultant of these bottom forces first with the upper force later. So this is the resultant. Let's call that F1. So supposedly this is half of 45 and that's also half of 45, but let's just verify. But that is anticipated 22.5, 22.5. Anyway, this is 45 degrees, so this is 180 minus 45, so 135 degrees. And F, so we can express F1 in terms of F by cosine law. We will call that alpha, but alpha is 22.5, anticipated, half of 45. This is also 22.5, but let's just call it alpha. This is also alpha. So F1 square by cosine law equals F square plus F square minus 2 times F cosine of 135. So F1 in terms of F is 1.848 of F. Then having found F1 in terms of F, then we compute alpha by sine law. F1 as to sine 135, 1.848 F as to sine 135 equals F as to sine alpha. Cancel F, so we can solve alpha. As anticipated, 22.5 degrees. So if this is 22.5 degrees alpha, let's form another parallelogram between F1 and the remaining F there. So this is the resultant of magnitude 1200 newtons, and alpha is 22.5. 22.5 plus 25 is 47.5 interior angle of this parallelogram. So the measure of this angle is 180 minus 47.5 is 132.5 degrees. This is F1, which is 1.848 F by cosine law. 1200 square equals F square plus 1.848 F quantity square minus 2 times F 1.848 F cosine of 132.5. So from here, let's simplify the right side first. 1200 square equals 6.912 F square. So we can now compute for F. F is 456.4 newtons. Level 8 problem. The force R is the resultant of the forces P1, P2, and P3 acting on the rectangular plate. Find P1, so this is just magnitude, and P2, magnitude of P1 and P2. If the magnitude of the resultant is 40 kilonewtons and the magnitude of P3 is 20 kilonewtons. So this is the figure. The magnitude of the resultant is 40, therefore X component of the resultant is 40 cosine 30, positive. The Y component of the resultant is 40 sine 30. But before that, let's solve for the angles that each P1 and P2 makes with the x-axis. So for this angle here, this is arctan of 600 over 300. Arctan of 600 over 300 in your calculator is 63.45 degrees. For this angle here, this is arctan of 400 over 300. So that's 53.13 degrees. So Rx, which is equal to 40 cosine 30, equals P1 cosine of 63.45. So Rx is 20 square root of 3. 20 square root of 3 Rx equals P1 cosine 63.45 plus P2 cosine of 53.13. Both are positive x components. They have positive x components, then minus P3, which is 20, going to the left. Simplifying, P1 cosine 63.435 plus P sub 2 cosine of 53.13 degrees equals 20 square root of 3 plus 20, 54.641. Call that equation 1. Then Ry is magnitude of R 40 sine of 30, positive, going up. So Ry is 40 sine 30 and it is equal to 20 kilonewtons. So equate 20 to the y component of P1, which is positive P1 sine 63.45, then minus P2 because going down, minus P2 sine 53.13 degrees, then equals 20. P3 has no y component. Call that equation 2. So solving equations 1 and 2 simultaneously, we get P1 equals 62.29 kilonewtons and P sub 2 44.64 kilonewtons. So level 9 problem, determine the resultant of the force system shown below in two methods. So I put this in level 9 because there are 4 forces. It's lengthy but not necessarily difficult or challenging. So by component method, this is 13. So take note that we have 75 plus 25, 100, and this is vertical, the horizontal line, and the vertical must form 90 degrees. So since this is 100, it means that the 350 Newton force is 10 degrees above the x-axis, horizontal axis. And 450 is inclined up. This is 15 degrees inclined upward by 15 degrees, 25 minus 10. 10 degrees, 350 inclined up to the left. 450 is inclined 15 degrees above the horizontal. So therefore, Rx is beginning with 520, negative 520 times 5 over 13. 350 is also negative. 350 cosine of 10. Remember, this is 10 degrees. Cosine of 10. Then 450 is positive, pointing up, 15 degrees above the horizontal. So plus 450 cosine of 15 degrees. Then 400 has no x component. So simplifying, Rx is negative 110.02 newtons. Ry is 520 is positive, 520 times 12 over 13. Y component of distance divided by distance. 350 is positive, it is pointing upward. Remember, its angle with the horizontal is 10. So plus 350 sine of 10. 450 is upward also, making an angle of 15 degrees. So 450 sine of 15 degrees. And of course, 400 is upward plus 400. So calculating, Ry is 1057.25 newtons. From there, we can compute the magnitude of the resultant, square root of 110.02 square plus 1057.25 square. You may make this positive if you want. In a way, when you square it, it's positive. So 1063 newtons, because we are required to determine the resultant, so it must be coupled with direction. So since the resultant lies in the second quadrant, if you may present the answer in standard form R 1063, then 180 degrees minus arctan of 1057.25 over 110.02, absolute value, remember. But let's have it another way, alpha. This is the reference angle. So alpha is arctan of 1057.25 over 110.02. So alpha is 84.06 degrees. So one way of expressing the answer is R is 1063 newtons, and you have to specify the angle or the direction. That's it. The second solution is by standard angle, so that we will not think of the sine anymore. So the angle that 520 Newton makes with the vertical is arctan of 5 over 12 is inverse tangent of 5 over 12. This angle here is equal to this angle. So 22.62. Therefore, the angle that 520 makes with the positive x-axis is 90 plus 22.62 is 112.62. So Rx is 520 cosine of 112.62. Remember that 350 newtons is 10 degrees above the negative x-axis. So its angle from the positive x-axis is 180 minus 10, 170. So plus 350 cosine of 170. 170 is 180 minus 10, 10 degrees. The reference angle of 350. Then plus 450, because this is the positive x-axis and that's 15 degrees. So plus 450 cosine of 15 degrees. And lastly, 400, the angle that the 400 Newton force, this is the line of action of the 400 from the positive x-axis is 90. So plus 400 cosine of 90. So I just put it there in a way that is 0, cosine 90 is 0. So Rx is the same, negative 110.02. Ry is, you just make all this sign. So Ry is 520 sine 112.62 plus 350 sine 170 plus 450 sine 15 degrees plus 400 sine of 90 degrees, which is 400. So Ry is 1057.24. So there's a difference because of this angle. So the magnitude is the same. R is 1063 because the components are the same. Then this time, let's have the standard form of the angle. Theta is 180 degrees minus alpha or arctan of absolute value of 1057.25 over 110.02. Remember, when the resultant lies in the second quadrant, then the standard value of the angle is 180 minus arctan of absolute value of Ry over Rx. So theta is 95.94 degrees. So that the answer is R 1063 at theta equals 95.94 degrees. So it is understood because if you express this in vector form, 1063 cosine 95.94 degrees I plus sine 95.94 degrees J, it will give us the X and Y components respectively. So levels 10 and 11 are challenging. The three forces acting on the beam can be replaced with a single equivalent force R. Determine the angle theta and R. So this is resultant. So this is a vector, boldface. That's it. So since we can replace this with a single force, meaning to say the forces are concurrent. So let's do another figure and let's extend the line of action of its force so that we can see that they are concurrent there. So that's the single force R. So from the figure, Rx is 25 cosine 40 positive plus 60 cosine theta positive, then minus 80 cosine 50, it is negative. So simplifying, Rx is 60 cosine theta minus 32.272. Ry, all forces are positive. So Ry is 25 sine of 40 positive plus 60 sine theta plus 80 sine of 50 degrees. Simplifying, Ry is 60 sine theta plus 77.353. Now, let's draw a line from this intersection down, perpendicular to the beam. Let's call that Y, and let's call this X. So we have two right triangles with common height Y. So in the left triangle, tangent of 40 is Y over 4 plus X. So Y is quantity 4 plus X, tangent of 40. So if this is X, then this adjacent side of the other right triangle is 6 minus X. So Y is 4 plus X, tangent of 40 degrees. Then in this triangle, in the right part, tangent of 50 is Y over 6 minus X. So y is quantity 6 minus x tangent of 50 degrees. So equating y's, 4 plus x tangent of 40 equals 6 minus x tangent of 50 degrees. So factor out x quantity tangent of 50 degrees plus tangent of 50 degrees equals 6 tangent 50 minus 4 tangent 40. So we can now solve for x, 6 tangent 50 minus 4 tangent 40 all over quantity tangent 40 plus tangent 50. So x is 1.868 meters. Substitute in this equation to solve for y is 4 plus 1.868 tangent 40. So y is 4.924 meters. We can now solve for theta. Tangent of theta is y over x. Tangent theta is 4.924 over 1.868. So theta is 69.22 degrees. Hi there. Uh, if you're able to think of the solution, then you're good. But if you don't have idea, this is just mathematics after all. Oftentimes, the mathematics can make the problem difficult in statics. That's why you need mathematical background to analyze well the four systems. Next is substitute here, Rx 60 cosine of 69.22 minus 32.272. So Rx is negative 10.99 kilonewtons. Ry is 60 sine 69.22 plus 77.353. So Ry is 130.4 kilonewtons. So since we are required to determine R in vector form, so let's express our answer in vector form so that there will be no issue. R is negative 10.99 I plus 133.4 J kilonewton. So there's no issue because this is a vector. Lastly, determine the resultant force R that is equivalent to the forces exerted by the three tugboats as they maneuver the barge. Specify the coordinate of the point on the x-axis through which R passes. So this is the figure, and they are concurrent because the resultant of these two will definitely intersect this 32 kilonewton. So we can reduce the system to just two force systems that are concurrent and coplanar, of course. So first, to analyze this, let's have the resultant of these two by parallelogram law. Draw parallelogram, tips, parallel, tips. Then that's the resultant R. Then let's call this angle with the x-axis of F1 as alpha. So the angle that F1 makes with the 32 kilonewton load is 20 plus alpha. So one interior angle is 20 degrees plus 35, which is 55. Therefore, this is 180 degrees minus 55, 125 degrees. Then by cosine law, F1 square equals 32 square plus 40 square minus 2 times 32 times 40 cosine of 125. So the magnitude of F1 is 63.97 kilonewtons. Then, by sine law, F1, 63.97 as to sine 125 equals, this side here is 40 as to sine of 20 degrees plus alpha, or alpha plus 20 degrees. Then alpha is inverse sine of 40 sine 125 over 63.97 minus 20. So alpha is 10.81 degrees. So to analyze, let's draw the F1 and its extension. And let's draw another figure here. So this is F1, 63.97 kilonewtons. It intersects somewhere here at B. This is the 32 kilonewton load. Then upward, right, up and to the right. So therefore, this is the resultant. It will intersect the x-axis, and we'll specify the intersection with the x-axis from B as xB. Then we will call this YB, YA, YB. So we can solve for YB by tangent function. Tangent 10.81 degrees equals YB over 60. So tangent of 10.81 degrees equals YB over 60. So YB is 60 tangent 10.81. So YB is 11.456 meters. Then let's call this beta later. Rx is 63.97 cosine of 10.81 degrees. This has no x component, so Rx is 62.83 kilonewtons. It is represented by this component here. Ry is upward 63.97 sine of 10.81 plus 32 kilonewtons. So Ry is 44 kilonewtons. Then let's call this angle beta. The magnitude of R, square root of 62.83 square plus 44 square, although not required. We may express our answer for R because this is a vector in vector form later. You might like the resultant and the angle if you want. So let's call this angle beta. So that tangent of beta is xb over yb. Yb has been found. And it is also equal to Rx over Ry. Tangent beta equals xb over yb, 11.456. It is also equal to Rx, which is 62.83 over Ry, 44, because that's Ry. So we can now solve xb. 62.83 times 11.456 over 44, 16.36 meters. So R is 62.83I plus 44.00J kilonewtons, and it passes through this point here with coordinates xb 16.36, then y is 0 at this x on this x-axis. That's it for this challenging problem.